pulling out one of the elements, and I had it in a set of tweezers, and I was showing people, and I was talking, and I squeezed the tweezers too hard, and then a chunk of lithium just went flying, and we couldn't find it. So I don't know if it's somebody's hair, somebody's pocket, or whatever.
Somebody just stole your lithium.
Luckily, lithium is the least reactive of the few things that I showed them, so it was a 10-minute worry, but then everybody made it back to class. No.
You won your physics class a week ago.
Yeah. So anyways, I'll try not to do that again. The name of that column is the Alkali Metals. Do you guys know what the word alkali means?
No.
Good guess. It's wrong, but okay. Twice for trying. Anybody? Very close. It's the exact opposite of that.
Basic.
But it's the same right idea. It's basic. It's an old-fashioned name for basic. And the reason that the alkali metals are called alkali metals is, well, they're metals. And when they come into contact with water, they always make a basic solution. And the reason is that all of them react with water. They split water apart and make hydrogen gas, which bubbles off. And then what's left behind is the hydroxide ion, which is what's released when any base reacts with water. So you make a basic solution. And just to show you that these are basic, I just took a bit of universal indicator solution, put in some water. Universal indicator changes color depending on the pH of the thing that it's mixed with. We're recycling chemicals. Good times. So I just want to get this so that it's not as dark at the start. Okay. So I'm starting with something that is slightly on the acidic side, which is that yellowish color. And then if it were to go basic, it's going to go towards greens and blues. So we'll see that happening as the reaction goes on. Now, all the members of that first column, with the exception of hydrogen, are alkali metals. Hydrogen's special. It's kind of a family of one on its own. And we're going to see how the chemical reactivity of all this is pretty similar. So I'm going to grab the lid. Okay, so all of these alkali metals, they look all oily. The reason is that they're stored in oil. They're not intrinsically oily. And the reason they're stored in oil is that all air has what sitting in, or dissolved in it? Hydrogen. Water. Okay. And the water in the air will react with these things, and so they're covered in oil because oil and water don't mix. They repel each other, right? And so that keeps this relatively safe to handle. If it were to touch my hands, the oil would be a barrier between the sweat and the lithium, and I'd be okay. So what we're going to do is drop it in the water. It's not an instant reaction because the water has to kind of work its way past the oil, but you'll see what lithium does in water. And if the color changes to a green or a blue, then we will have observed the alkaline nature of it. That's so fun. What's that? It just takes a minute to get through the oil, and then once it gets through a bit, it speeds up.
Can we put potassium in the water?
We're getting there.
Okay.
See that trail of blue behind it? It is dense enough that it should sink, but it's acting like its own little hovercraft. It's creating gas underneath it, which is pushing up on it so it doesn't sink. And the color change there, is it alkaline, basic? Yes, it is very basic. Now, that's kind of interesting. You know, you put a chunk of metal in and it floats and it makes bubbles, but was it all whiz-bang and super cool or just meh? Meh. Okay. And that's because we're at one end of the the scale in terms of alkali metals. That's the top alkali metal. Next one down on the list is sodium. Grab some sodium. And so here's the sodium. The side that's been exposed for a bit is a bit pinkish. Okay, a bit dull pink. And then the side I just cut, it's nice and shiny. And it's a nice soft metal. And actually, as you get more metallic, metals actually do get softer in general, not harder. I would. Oh. And you okay with me putting this one in? Even though that one's not finished? Okay. Yes? Let's do it. Okay, so we drop that guy in. Same basic reaction, but a bit more violent. And it's releasing energy a lot faster, and it's actually warm enough that the hydrogen that was coming off, that comes off in all of these reactions, is warm enough to ignite. And so we get those little flames. Maybe it'll ignite again. That's kind of cool. Again, it is dense enough to sink, but it's its own little hovercraft, which is kind of cool.
Oh, Sophie. I mean, not Sophie. Tony. Names that start end with E. Oh, I shouldn't be doing this in 4 hours of sleep.
And so, we seem to have established a bit of a trend. So going down the column, it seems to get more violent. Now, after seeing 2 examples, can you be sure it's a trend? No.
We need to see it in the pattern.
Francium!
Yeah.
Potassium is a very soft metal.
Okay, good.
Cutting it, it's about the same consistency as cutting tofu. Okay? So this one's kind of a purplish when it's oxidized, and then there's the cut shiny surface underneath. And for this one, we're moving it back, and we're closing the fume hood. We'll turn off the light, because that'll make it more fun. Everything's better in the dark.
I can't see. I can't see.
Whoa!
You have to redo it again.
It usually doesn't pop. See it sparking.
No.
You missed it?
Yeah, I saw it. Why?
Let's do it again. Little bits of potassium flew up when it blew up, but didn't have a chance to react. So there's probably some different spots. No.
It's gonna smell fantastic.
It's not Febreze. Do you want me to do that one again? Yes, please.
I have a feeling if you peer pressure him enough, he'll put the entire class in danger.
I actually have a friend who, when he was at UBC, and they were doing this demo, they actually left a baseball-sized chunk of potassium in a jar, like this one, out at the end of the class, and he stole it. And he tossed it into the ocean by Kids Beach. And they thought it'd be, it'll be a cool purple flame, it'll be nice, yeah. They're all knocked to the ground. They probably killed a lot of fish. And
I wanted to do that.
nobody found it.
Go the other way. Go the other way. Go on the other side.
Don't go on the other side. There was no boom boom. I know.
What happened?
Where's the boom boom? There's the boom boom.
You need to do it again.
So, the next one on the list is
I don't know. I can't see.
Rubidium.
rubidium. I can't buy rubidium.
So we're skipping that and going to the next.